Can you make water defy gravity? Stick around to find out. Hello and welcome to Science at 6. My name is Mia and I am this week's presenter in the centre. You can find out where to get our activities in the description below, and if you have any questions just email us at openupscience@cambridgesciencecentre.org. This week I'm going to show you how you can make water defy gravity and create a fountain inside of a bottle. So for this you will need a kettle, some water, a bowl with some cold water in it. I've put some food colouring in mine, a glass bottle, a straw, some plasticine and some heat protective gloves or oven gloves. So the first step is to pour some boiling water into a glass bottle with the help of an adult. Now this is just so that the glass bottle warms up, so I've done this before we filmed the show. Next step is you need to wrap the plasticine around the straw. So it should have about 1 or 2 centimetres showing at the base and the long side coming out the other end. And the plasticine should be as wide, if not wider, than the neck of your bottle. Next thing we need to do is put on our heat protective gloves and empty out the boiling water from the glass. So now we just have a hot bottle. I'm going to put the straw in long ways down and squeeze the plasticine so that it's sealed around the rim of the bottle. Now, here comes the cool bit. Grab the bottle, tip it upside down and put the end of the straw into the cold water. There you go. Wow. What was happening there? Well, when a bottle's empty, it's not really empty. If it's not full of water, it's full of air. When we put the boiling water into the bottle, it warms up the glass. So when we empty the water out, we just have a glass full of hot air. Now when air gets hot, it expands, and when it cools down, it shrinks. This is called thermal expansion. When things get hot, they get more energy. So their volume increases and the density of the air decreases. This means that the density of the air inside the bottle is less than outside. When I put the stopper on, I'm trapping the air inside the bottle, the stopper being the plasticine. So this means that the air inside the bottle is less dense than the air outside. No air can get in or out, so the density stays the same, but over time, the temperature starts to decrease. But the volume can't decrease because we've got a stopper on. And so the pressure inside the bottle decreases, meaning the pressure inside the bottle is less than the pressure outside of the bottle. Now, if I were just to take the stopper off, then more air would rush into the bottle and it would be equalised. But the straw is a much more entertaining way of getting this to happen. When I put the straw upside down into the cold water is pushed up the straw and into the bottle, trying to equalise the pressure. When the bottle cools down enough, then the air will stop pushing the water into the bottle and the fountain will stop. Thanks for watching, and as ever, if you have any questions, send them to openupscience@cambridgesciencecentre.org.